Welcome. So in part A of this, we did the code and we found some values for different step sizes. Right here, we defined the step. Now, I would say they asked us to do two more things. The first thing was to find an explicit solution. So to find an explicit solution, I would say this is dy over dx. And I would say that this is 2xy. So this looks like it could be solved by separation of variables. So if I divide by y, I get 1 over y dy equals to 2x dx. Now I can take the integral on both sides. What do I get? Well, here I'm going to get the natural logarithm of the absolute value of y. I'm going to combine all the c's together. Here I'm going to get 2 times 1/2 times x squared plus c. So I can rewrite this as just x squared plus c. Then I can exponentiate both sides of this. And now this answered the question, e elevated to the power that I need to raise e to the get to y. Well, that's just y. And we're assuming we know that y is going to be always positive. Here we're going to get e to the x squared. And we can decompose this as e to the c. And we can say that a is equal to e to the c. So now we'd have y is equal to a times e to the x squared. And this would be our explicit solution. So this would be an explicit solution. But now we need to put in the initial conditions to find what a is. So let's do that. If I put our initial conditions, which they said is y1 is equal to 1, so 1 happens when we put 1 into x. So here we get 1 squared, which is just 1. So now our a is equal to 1 over e. So now we can rewrite the solution as y is equal to 1 over e, which is the same thing as e to the negative 1 times e to the x squared. Using the property of exponents, we can say that e to the x squared minus 1 is equal to our answer. And now we have an explicit solution. So now I would say let's go back into MATLAB and let's modify this code so that we also define an actual y, sorry, this color can't really be seen. Now we can put in here we can put an actual y of x, which is going to be our solution, explicit solution. So e to the x squared minus 1. And then what we can say is let's define something else, say the error, and let's say that the error is going to be y of n plus 1 minus y of x, and we probably need to give it some name here, so maybe x naught y of n plus 1 here, and the absolute value of that divided by what it should have been, which is what comes from this, because this is the actual solution, and then multiplied by 100, and that'll tell us the error. And then we can do it with different steps, sizes, and see which one gives smaller errors. So let's go over to MATLAB and let's try and figure out how to do that. See you there. For part C at this point.